A data frame is R's version of a spreadsheet, which is a little bit more tricky to work with than if you were to work with one in Excel, but it's a lot more powerful and you can do a lot more things by working with data in R than you really could in Excel easily. So let's open up an Excel spreadsheet called tips.csv just to remind ourselves of what a spreadsheet looks like. We have different columns, each of which has a name, and this data set deals with the amount of money people are spending and tipping at a various restaurant. So each row of the data frame represents a different table, and the columns represent characteristics of that table. So for instance, this table spent $21.01, leaving $3.50 as tip. They were non-smokers. They visited on a Sunday at night with 3 people in their party. So how do we get data into R and have it act like a spreadsheet here? That's a data frame in R. And then how can we work with it to do analytics? So let's start out actually by just making a data frame manually. So there's a special object called a data frame in R, and we can construct this on the fly if we see fit. So we'd be using the data.frame command, and all we need to do is give vectors as the columns of the data frame that we want. So for example, imagine we created 3 vectors, x, y, and z. We can construct a data frame with those as the columns and give those columns a name with the following procedure. So let's give our data frame a name. Actually, I'll call it data in all caps. My convention is to always name data frames in all caps. And let's left arrow that to the output of running the data frame command. Now the arguments of the data frame command, what we'll do is we'll come up with a column name that we want our first column to have. Maybe we want it to be volume. And we'll say volume equals, and we'll give it a vector of values we want that to have. So let's say volume is the x values, the amplitude are the y values, and the settings column is going to be the entries in this z vector, this categorical variable for A or B. So if we run this, we can look at the contents by just running the command to a screen. So we would find 3 rows, 3 columns, they're labeled appropriately, and we also see that it appears in the global environment. We can click on the arrow next to the name of a data frame to get a small preview of what's inside that data frame. It's small enough to see the whole thing. But that's one way to create a data frame just on the fly. Notice that if we didn't actually give names to each of those columns and we just had as the arguments to data.frame, x, y, and z, the vectors that contains the values we want in the data frame, it actually would have just defined the names of the columns after the names of the vectors we put in there. Now, most of the time, we're not defining data frames on the fly. We're either using built-in data frames in R, either in libraries or in base R, or we're reading in data from an external source. So let's go over how we get data in these various methods. So there's a large number of data frames that just come with R. You've installed R, and so you can load up some of these data frames just by invoking the data command and then saying the name of the data frame that you wish to load. So I happen to know that there's a data frame called air quality that's built into R. So if I say data air quality and run that as a command, what will happen is I'll see that it gets put into the global environment. We see there's 153 observations with 6 variables. I can get a preview of what's contained in it. And that would be one way to get a data frame into R. The other way is if a data set lives inside of a package, like the reg class package, we'd first have to load in the relevant library, but then we can load in that data set with the data command, provided that we know what the name of the data source is, here cust value. So we see it getting put into the global environment, and we'd be able to start doing analytics on it. Now, you'll notice in this first data command, I had the name of the data frame without quotes. In the second data command, I had the name of the data frame with quotes. It turns out this is one of the very few commands where R allows you to either keep or omit the quotes and still have the command run properly. So either or is fine in this case. Most other commands, you have to do it one way or the other. All right, well, what if you've downloaded some data off the internet? Maybe you've got some from your boss. How can you get in a file into R and have it be treated as a data frame? Well, for the most part, what we'll be doing in this class is using the read.csv command. CSV stands for comma separated values. So it's assuming that if you were to open up that file in, say, a text editor, each row would correspond to some entity you're studying, and the characteristics of those entities are just separated by commas. So the tip, the party size, etc., just separated by commas there. So if our data does live in a comma delimited file, how can we get that into R? Well, we'll be running the read.csv command, and really the only decision we have to make is, do we want the text variables to be treated as text, or do we want them to be treated as factors, as categorical variables? And let's do this both ways. So I have a data file called tips.csv, and it lives on my laptop. The link is in the video description. And let's go ahead and read this into R, giving it the name tips in all caps. So we'll use the left arrow notation to define the object called tips to be the result of running the command read.csv. So what we'll do is, in quotes, put the name of the file. And we have to have quotes surrounding the file name tips.csv. And then I'm going to add in an additional argument called stringsAsFactors. And I'm going to start this out by saying this is going to be equal to false. And this is what I will do whenever I need to read in the text and keep it as text in the data frame. So if I run tips left arrow read.csv, I see tips is now in the global environment. If I click on the arrow, I see that that spreadsheet that I had originally opened in Excel has now been translated and stored into R. And the text variables like male, female, smoker, yes or no, day of the week, we see they're being treated as text, just character variables. So if we wanted to have this happen the other way around and have those text variables be treated as categorical variables so we could do analytics on them, it's just a very small change. Instead of saying stringsAsFactors equals false, we're going to say stringsAsFactors equals true. And we'll notice that gender, smoker, day, and time are now categorical variables. For the most part, we'll be reading in data with stringsAsFactors equals to true, because if there was a column that we needed to have be treated as text, we can always convert that into text very quickly. So how could we do that? Just to show you, we'd refer to the column name with a $sign and say maybe tips $smoker. We could say as.character and take out the values in that column, run it through the as.character command to convert that into just text by itself. So normally we'll be reading in text variables as categorical variables. The only time we'd probably want to preserve that as text is if they were maybe a column of text reviews, maybe reviews for Amazon products or products that you find on Walmart or something. So normally the data that we have is best treated as categorical variables, so stringsAsFactors equals true makes sense, but we can convert it to text fairly easily. Now you can also read data directly in from the internet. Now normally you'll have to use a related command to read.csv called read.table, because you have to give it a little bit more information about the structure of the data file. Does it have a header? Are the entries separated by commas or tabs or return characters? So I just want to run this line of code as an example where we're going to a website where there is some data file living there, and I'm reading it in directly from the internet. And so if I were to look at the global environment, sure enough, I would have a data frame called diet, and this is about weight loss. We have the subject number, their initial weight, and their terminal weight after the diet. Now, one great way that we'll be reading data in BAS 320 is by loading in saved environment files. So right now, the global environment has a ton of different objects that are created. We have the air quality, cust value, data, diet, tips data frames here. Remember, we can go to session and save workspace and actually save all of these objects into a .rdata file right here if I give it a name. So maybe some things. So let's talk about how we can load in data that's stored as a saved environment file, an RData file. So two ways. And I think my favorite way is usually going to Session from the top menu and then going to Load Workspace. A saved environment file is known as a workspace. And so when we click on this, all we have to do is navigate to where that RData file is. And in this case, what I want to do is I want to load in this RData file called BAS 320 Datasets Fall 2023. And once I open this, it'll populate the global environment with all the data frames, all the objects that were stored in that RData file. So a lot of different data files that we're going to be able to analyze in this class. The other way to do it, actually, if I clear out that global environment, let's start out fresh, is if your working directory is set up correctly, if the path that R is looking for files happens to be where that data file lives, you can use the load function. Put in quotes the name of the RData file, and it'll load it in there for you right quick. So once we've got data into R, what are some good things that we can do to explore? Well, one thing that we like doing is checking out the size of our data frames. How many rows, how many columns, what are the dimensions of the data frame? So what I'm going to do is load in the reg class library and then load in the bulldozer dataset. This contains the information on 924 bulldozers that were sold at auction, and I can see that I have 6 variables that I've recorded for each of these bulldozer sales. But if I didn't look over to the right at that environment window, I could actually figure out the number of rows, the number of columns, etc. with the following commands. Dim, if I run that on Bulldozer, is going to let me know the dimensions of the data set. The first number is the number of rows. The second is the number of columns. I could get the number of rows just by running nrow on Bulldozer. I could get the number of columns by running ncol, as you might expect. And very often I like to look at the first few or maybe the last few rows of a data frame just to take a survey of what the data looks like. And head and tail are very useful commands to actually look at this preview. So if I were to say head bulldozer, what that's going to do is by default, it's going to print out the first 6 lines, the first 6 rows of that data frame. So I can see the sales prices, I can see the years ago, when that auction occurred, etc., etc. If I wanted to see more or less, I can just add in a comma and then say how many rows I want to see. If I just wanted the first 2 rows, comma 2 would take me there. Likewise, tail is going to show the last few rows of a data frame. So for example, if I wanted to see the last 4 rows of the bulldozer data frame, tail bulldozer, comma 4 is going to get me there. Now, alternatively, what you can do is you can actually double click on the name of one of the data frames in the global environment, and that'll bring up the view panel. And this kind of looks like a spreadsheet like what you would see in Excel, but you can't edit it, you can't click on it, you can scroll up and down to look. So, you could use this to your heart's content, but this is not usually an operation that we do in R, because if we do want to look at the contents of a data frame, we're going to be printing out the contents of the screen with head, tail, or if we want to look at particular rows or columns or cells, we have ways to do this. So let's talk about how we can glimpse inside of a data frame, look at particular cells, look at particular rows and columns. So because a data frame is a 2-dimensional object, we have rows going up and down, we have columns going left and right. To make a positional reference in a data frame, we're going to need 2 numbers. Now, just like we made positional references with a vector, we're going to use a set of square brackets, but inside those 2 square brackets, we're going to have to put in 2 numbers separated by a comma. The first number is going to refer to the row position. The second number is going to refer to the column position. So for example, if I wanted to know what value is inside the 8th row in the first column of the bulldozer data frame, I would type out bulldozer, put in some square brackets, immediately put in a comma, since this is a data frame. To the left of the comma is the row that I want to refer to, 8th row, comma 1 for first column. So 77,000. What about the 10th row, 3rd column? Well, same sort of operation. I'll put some square brackets after the name of the data frame, put a comma inside those. To the left of the comma is the row number. To the right of the comma is going to be the column number. And there we go. So of course we could refer to multiple rows and multiple columns all at once. Let's say we wanted the 10th through the 12th row here and the 1st through the 3rd column. Well, same sort of thing. We type out bulldozer, put in square brackets, put a comma right in the middle. To the left is our row reference. We want the 10th, 11th, and 12th row, so we'll give it a vector of rows that we want. We can use that integer shortcut 10:12. That's going to be that integer sequence 10, 11, and 12. And likewise, the 1st through 3rd column 1:3, 1st through 3rd column here. This would give us rows 10, 11, and 12 for columns 1, 2, and 3. Now, if we want to refer to the entirety of a row, all we have to do is leave the column information blank. If I want to know what the 10th row of the bulldozer data frame was, I can just put in square brackets 10 comma, and then leave the column reference just ambiguous, blank here. And this will print out the entirety of the 10th row. And once again, I can put vectors in if I want multiple rows all at once. To get the 10th, 15th, and 18th row, I could give it the vector 10, 15, 18, leave the column reference blank, and I would get the entirety of those rows. And just like what we referred to with positions and vectors, I can use the minus sign to exclude various rows. If I were to go and put inside the head function, let's say the bulldozer with a minus C10, 15, and 18, This is referring to everything but the 10th, 15th, and 18th rows. And if I look at, say, the first 20 rows of the resulting data frame, I can see scrolling up and down, there's no row 18. There's going to be no row 10. I've excluded those rows from reference. Now, to refer to columns of a data frame, there's actually a few different ways. So let's figure out how we can refer to the usage column, the number of hours that these bulldozers have been used when they were put up for auction. So the first way is to essentially leave the row information just completely blank. If I were to say bulldozer and then bracket, comma 4, well, the row information goes before the comma. If I just don't put a number there, it's going to say, okay, well, I'm going to do all rows, but just with the 4th column. If I were to print that out, I would get all the values in my usage column here. The other way to do that is very similar, but instead of referring to the position of the column that you want, usage happened to be the 4th column, I knew that. If I didn't know where in the data frame that column was, I could refer to that column by name. So if I wanted the usage column, I could say bulldozer bracket, comma usage, leaving the row reference blank. Now, my favorite way, and a little bit of this is because you'll have great salaries after graduating with an analytics degree, is to, after the name of the data frame, put in that $ for all that money you're going to be making. This will actually bring up an autocomplete where you can scroll up and down. You can see all of the columns that live in that data frame, and you can either type it out manually or just select it from that list. So this would refer to all the values in that usage column. And so this brings up a really good point. If we do want to make a particular reference to a cell in a data frame, there's actually a pretty effective way if we know what column that cell lives in. So for example, if I wanted to know, well, what is the 6th row in the usage column, I could say bulldozer $usage, extracting out the usage column, and then put a square bracket, and then put a 6 in the middle here. So this would be the 6th bulldozer's usage in the data frame. So how do we know what these data frames contain? What are the column names? Well, we can always go back and click on the arrow next to the name in the environment to see what those names are. But there are some other ways as well. The names function, if you give it the name of a data frame, will print out a vector, a text vector of all of the different column names. And if there's a lot of different names there, sometimes I like putting that inside the data frame function, because in this way you actually get a list of the column names themselves and also what positions they were, which column number they were in the data frame. Now, of course, we can rename columns in a data source if we want to. Let's go ahead and rename some columns for the bulldozer data. I'm actually going to make a copy of the bulldozer data by left arrowing it into a new object called bulldozer.mod, so I don't ruin the original data source. So bulldozer.mod is right here, and maybe what I'd like to do is I'd like to rename that first column sales price to be a little bit more explicit, sale price in dollars. I could type out bulldozer mod, and then what I need to do is extract out the names of that, so I'll put that inside the names function. Sale price is the very first element, so if I put a bracket 1, that just refers to sale price, and I can redefine that on the fly just with the left arrow symbol and then typing in the name of the new column that I want. So sale price in dollars, I'll just copy and paste that in the quotes, and we'll see that's immediately reflected in the global environment. And if I were to look at the names of the bulldozer.mod data frame, that's been updated. And we can rename multiple columns simultaneously. If I were to say, let's take the names of bulldozer mod here and rename them all at once, I need to give it a vector with 6 elements because 6 columns here. So maybe I'd say var1, var2, and so on and so forth. So as long as I've matched up the number of column names with the number of entries in this text vector that I want to have those names to have, I'll be able to run that and we see that that change takes place immediately. Now, what if I wanted to add additional columns into my data source? So for example, with the bulldozer data frame, I have 2 columns that refer to the blade size and the tire size. Maybe I want a new column that's the ratio between these two. Well, it's very easy to add a new column to a data frame in R. Well, all you need to do is type out the name of the data frame that you want to be adding the column to, and then add that $, and then say what the name of the column you want it to have. In this case, let's call it blade to tire because it's going to be a ratio. And then you'll left arrow that to be the calculation that's going to give you the numbers you want to use to populate that column. So here what I want to do is I want to take out the values in the blade column here. So to take out the values in a column, bulldozer $ blade here. And because R does vector arithmetic, we can take a vector and divide by another vector. So bulldozer $tire is going to take the ratio of the blade to tires for each one of the bulldozers in the data set. If I run that just by itself, I get what all these ratios work out to be. I can left arrow that to be the $blade to tire column in the bulldozer data set, and I see that it's been added. Now, what if I don't really want that? What if that's a mistake? What if I want to get rid of it? Well, to take out a column from a data frame, we can null it out. So how would I do that? Well, I would take the name of the data frame and $, the name of the column that I want to get rid of, blade to tire, and I'm going to left arrow that to a very special expression in R. Notice that it's all blue right now. Null basically means nothing whatsoever. There's no quotes around it, so it's not going to be the text or word null here. If I just left arrow it to null all by itself, it's going to completely remove or null out that column. Now, in analytics, very often we're going to work with subsets of the original data source. Maybe I only want to be looking at properties of bulldozers that sold for at least $50,000. So how can we take subsets of our original data frame efficiently? So in base R, and there are more advanced packages for doing data processing. You can look about the tidyverse, you can look at dplyr, etc. But in base R, the command that we can use to take subsets is subset. We're going to give it the name of the data frame. We're going to give it a condition on the rows that we want to survive the subset, that ones that we want to see. And then we can say optionally what columns we want to keep track of. By default, it'll take all columns in the subset, but if we only want a small number of those columns, we can specify those if we want. So what if I wanted a subset of these bulldozers where the sale price was at least $50,000? Well, if I type out subset, the name of my data frame is bulldozer. And the rows that interest me are the ones where the values of sale price, that's the name of the column, are at least 50,000. So all I need to do is type out the name of the column. I don't need quotes to surround the column names in this case, and then say what condition I want on the sale price. So if I were to take this and just run that as a command, it's going to print it out to the screen. Why don't I left arrow that into a data frame called sub? And so now if I get a summary of the values in sub, I can see that the sale price starts at 50,000 and it just goes up from there. All right, well, what about a subset where blade is 16, tire is 23? Same sort of deal. We can take the left arrow symbol and create a new data frame called sub, which is going to be the result of running the subset command on bulldozer. We just have to specify what rows we want to keep in our subset. So in this case, we want it where blade is equal to 16, tire is equal to 23.5. So we look up the column names, it's just blade and tire, and we'll specify the conditions that we want. So we need to check to see, are the blade values equal to 16 or not? When we check equality, we use the double equal sign. Remember, the single equal sign sets equality. It's the same thing as the left arrow symbol. We want to have blade double equal to 16 and have tire be equal to 23.5. The and is the ampersand symbol when we combine conditions. So tire double equal to 23.5. If we run that command, we've created the sub data frame. We can get a summary of this just to check. And sure enough, all the values in tire, 23.5, all the values in blade are 16. All right, well, we can look at the tips data set as well. In the reg class library here, there is a data frame called ex2.tips, so I'm going to load that up. And it's living in the global environment now. This is the same data frame that we read in with read.csv with slightly different column names here. And so what if we wanted to get a subset of this data frame where the day was Sunday and we only want to keep the bill and the tip columns here? So we would just want information on Sundays and bill and tip amounts. So how could we do this? Well, let's create a new data frame called sub, and we'll left arrow that to be the result of running the subset command on this ex2.tips data frame. So we need to know where the day is Sunday, and it looks like the column name that tells us this information is weekday. So weekday is going to be equal to Sunday. We got to surround Sunday in quotes because we're treating that as text, not a variable. We don't have to put quotes around the column names that we're using in our subset command, but we do need quotes around any sort of text where we're checking to see if those columns equal to that value. And that's the only condition on the rows, and we only want to keep bill and tip. I can put in the select argument here, select equals, and then I can give it a vector of column names that I want to keep. So in this case, I need to keep the bill amount, which is referred to as bill in USD, and I also need to keep the tip amount, which is referred to as tip in USD. So I run the subset command, I could get a summary of this, and I see that my subset contains only the bill and tip columns, and I've selected only those days that corresponded to Sundays. All right, well, another data frame that lives in R, doesn't follow my conventions, it's all lowercase here, is the air quality data frame. If I go all the way up and find where the air quality data frame is, we have some columns, ozone, solar radiation, etc. If I look at a summary of this air quality data frame, I actually find that some of these columns are missing values. 37 values in the ozone column are missing, 7 values in the solar radiation column are missing here. So maybe we would like to analyze a subset that either contains or maybe excludes missing values. Let's try to take a subset of the air quality data frame where we have solar radiation being missing. Maybe those rows we want to investigate a little bit further. So how could we do this? Well, I'm going to have the name of my subset just be called sub in all caps, and we'll left arrow that to running the subset command. First thing we put in is the name of our data frame. Second thing we put in are the conditions on the rows that we need to keep. So we want the rows where solar radiation is missing. There's 7 of these. And we can't use the double equal sign to do that. We can't say something like solar.r double equals to NA. R actually doesn't know how to check to see if something is missing or if it exists with the double equal sign. Instead, it has a special command called is.na. So if we ask is.na solar r, this is going to mean yes, let's select the ones where we have missing values Na in the solar radiation column. So if I take that subset and then look at a summary of this, I find that yes, all of those rows in the solar radiation column are missing here, and we could do some analysis on the wind speed, the month, etc. if we wanted. Now, normally we like throwing out rows with missing values. We like complete data. So if there's a good reason for throwing out the missing values, those rows with them, let's figure out how we can do that. Let's create a data frame called sub, which will be the result of running the subset command on air quality. But in this case, we want to make sure that the ozone values exist. So we want the ones that are not NA. And to do that in R, we'll do the exclamation point is.na. We'll kind of take the opposite of running the is.na command on the ozone column. And so when we do this and get a summary of our subset, what we'll find is that yes, all the values in the ozone column exist. There's still values in the solar radiation column that are still missing, but there we go. Now, another thing you might want to do with data frames is to sort them based on the values in a particular column. And in base R, sorting is kind of needlessly complex. This is why it's great to work with dplyr or the tidyverse. There are much more advanced commands for doing data manipulation and wrangling a bit more efficiently than what we find in base R. But we'll stick with base R and learn how to sort. Now to sort, we essentially need to reorder the rows based on the values that we find in a particular column. So when we do this, when we reorder rows, we're going to put a pair of square brackets right after the name of the data frame that we want to be sorting. And when we make that row reference to the left of the comma, we're going to use the order function and give it the values of the columns that we're using in our sorting. So let's just do an example. Let's try to sort the tips data frame by the bill amount. So if I were to look at a summary of the tips data frame right here, ex2.tips, the bill amounts can go from relatively small to relatively big. And let's sort this maybe from highest to lowest or from lowest to highest. So to do this, we're going to take the name of the data frame, we'll put some square brackets in it and a comma in between, and we're going to mess with the ordering of the rows. We'll leave to the right of the comma blank because we don't need to do anything with the columns, and to the right of the comma is the column reference here. And what we want to do is we want to order these rows by the values inside the bill column. So if I were to just run this as a command, it'll print the results out to the screen. And if I scroll all the way up to where that command actually starts outputting, what I find is that the way this is sorted it is from smallest up to biggest. The smallest bill, the second smallest bill, etc. And that's fine. But if I do want to do this the other way around, if I want the largest values up on top, all I need to do is inside that order command, add a decreasing equals true. We want this in decreasing order so that now when I run this command, I'll give it a little bit more space, and if I scroll all the way up, what I find are the biggest bills up on top, second biggest bill, third biggest bill, etc. And we can sort on multiple different columns. All we have to do is feed the order function multiple column names. So if I wanted to sort by party size first and then by bill, what I could do is I could say, well, let's not order by bill yet. Let's actually go and order by party size first and then bill. So if we want to sort by the values inside the party size column, I'll do $size of party and then put a comma and then the name of the column that I want to use as my second sorting, the bill in USD. We'll do decreasing equals to true. We'll print this out to the screen and we'll see that once we scroll up, we're starting with the big parties first, so 6, going down to 5, going down to 4, etc. And then for each party size, we see that the bill has been sorted from highest down to smallest. Not the most elegant looking command, but that's what we're stuck with in base R if we want to do sorting.